In this part, we'll be discussing the Rankine cycle. If you remember well, the Rankine cycle is the ideal cycle for steam power generation. It included 4 main systems. The first one was a pump, the second one was a boiler, the third one was a steam turbine, and the fourth one was a condenser. The role of the condenser was to reject heat to the surroundings and therefore fulfill the second law of thermodynamics. Now the question is, why actually are we interested in analyzing steam power cycles and Rankine cycle more specifically? Rankine cycle was the first cycle developed to generate power. Okay, from a historical point of view, steam was used to generate power. But then, because of its low efficiency, it was rapidly replaced by gas-powered cycles. However, some recent advancements, mostly in concentrated solar power generation, led to a revenge, if you want, or a comeback of a steam power cycle in the Rankine cycle. If you don't know what is CSP, just watch this video.
Okay, take the natural heat from the sun, reflect it against a mirror, focus all of that heat on one area, send it through a power system, and you've got a renewable way of making electricity. It's called concentrating solar power, or CSP. Now, there are many types of CSP technologies: towers, dishes, linear mirrors, and troughs. Okay, have a look at this parabolic trough system. Parabolic troughs are large mirrors shaped like a giant U. These troughs are connected together in long lines and will track the sun throughout the day. When the sun's heat is reflected off the mirror, the curved shape sends most of that reflected heat onto a receiver. The receiver tube is filled with a fluid. It could be oil, molten salt, something that holds the heat well. Basically, this super hot liquid heats water in this thing called a heat exchanger, and the water turns to steam. Now the steam is sent off to a turbine, and from there, it's business as usual inside a power plant. A steam turbine spins a generator, and the generator makes electricity. Once the fluid transfers its heat, it's recycled and used over and over, and the steam is also cooled, condensed, and recycled again and again. One big advantage of these trough systems is that the heated fluid can be stored and used later to keep making electricity when the sun isn't shining. Sunny skies and hot temperatures make the Southwest U.S. an ideal place for these kinds of power plants. Many concentrated solar power plants could be built within the next several years, and a single plant can generate 250 megawatts or more, which is enough to power about 90,000 homes. That's a lot of electricity to meet America's power needs.
Now that you see the importance of Rankine cycle and the specific application in CSP, we have to look into ways to improve the efficiency of this Rankine cycle. The way we'll proceed is the following, is that we will start by analyzing a simple Rankine cycle. We will restrict ourselves to the 4 Lego blocks, if you want: pump, boiler, turbine, condenser. We will be solving an example to know what is roughly the efficiency. Then what we will try to do, we will try to improve or increase the efficiency of our Rankine cycle while always keeping the 4 main components and the same processes. We will see what we get. And then after this, we will rapidly see that it wasn't enough. We will find some constraints. So therefore, what we'll be doing, we'll move on to another type of cycle called Rankine reheat. And then after this, we will calculate again our thermal efficiency. And we will continue and try to improve our cycle efficiency by introducing Rankine with regeneration.